want to see you go over, have questions about? The ones I'm seeing the most are 1, 2, and 3, so we do those 3. For number 1, if it's asking, is this direct, inverse, or neither? So without even seeing where this is going to end up on the y-axis, I know it's not going through the origin. So it can't be direct. It's not a hyperbola in the curve shape, so it's not inverse, so this would be neither. To find our line of best fit, we would use the calculator or Desmos for that. So I could go into this and make a table using all the ordered pairs. Negative 2, 4, 0, 3, and 5. And then I want to use Desmos again to find my line of best fit. So you're putting in y1, the squiggly line, the tilde, mx1 plus b. And you should get these two numbers. And you would write that in your line of best fit. Y equals, you could use 3 decimals, negative 0.423 x plus 3.09 if you're rounding. If you use more decimals, that's great. If you use less, you should be using at least 3 decimals. Questions on that one? And then for number 3, if you were doing this in Desmos, you could type this equation in. Find the slope of this line, which is 2/3, and then type in, really you don't even have to type anything in. So now that you know the slope of this line is 2/3, if it's perpendicular, you need the opposite slope, so something that would have a negative 3/2. And then you can pick whatever y-intercept you want. So y equals negative 3/2x, leave it like that. Have the same y-intercept at negative 2. Pick whatever you want. And that would be your equation. Questions on that? So I'm going to go through the SOL, all of A1. Make sure you have these answers down. If you want to see how something was gotten or anything like that, let me know. If you have questions about any of these, let me know. You don't need all the work, but at the very least, make sure you have these answers written down. So number 1 was 7, 2, negative 7. 3, 576, 4, 33, 5, negative 19, 6, negative 28, 7, negative 10, and 8, 13. So these were just taking whatever it said for the variables and putting them back in. Questions on any of those 8? once this packet is done, it's going to be a great study guide to use for the SLO. Number 9 should have been D. A and D were similar, but with A, 1/4 times, all of this would be together, less 5, you'd be subtracting 5 underneath the cube root. So that's why that one's different. So it should have been D. And then for your translating, D should have been, there wasn't really any variation. These should have been the answers. Notice where I put parentheses around in the words to say this goes together. The quotient of the square root of x and 5, so you're dividing. The cube root of the product of x and y, less 12. The comma shows that it goes after the cube root. The sum of the square root of 16 and the product of 4 and the cube root of 8. Now this one, the rest of this you don't need. I was just showing that you could simplify this because everything is in numbers. And then 4 times the cube of a number is 84. That is your equals. Questions on any of those 4? So when you're ready, go up to the next page. And then for 14, we have 16 divided by the sum of a number and 4 is 9. For 15, you really needed 2 different things. Amy is 4 years older than Jose, so if you knew Jose's age, you could add 4 to it and you would get Amy's age. Together, their ages add up to be 100, so you could take Amy's age equation and Jose and add them together to get 100, so either of those would be fine. For 16 and 17, your words don't have to match mine exactly. I just put something that would make sense. There are other ways to write these. But what I have is 5 times the cube root of the product of 4 and x, that was supposed to say subtracted by the square root of y. And then for 17, the sum of y and the cube root of x. Remember that these can be as simple or complex as you want them to be. 17, we could have said y plus the cube root of x. 16 had a lot going on, so somewhere you would have had some of those words regardless. Right. In Desmos, the evaluating piece, the first part of this, you can do no problem. Translating cannot be done in Desmos, so that's something you would need to know for the SLO. Questions on this? I'm going to give you the next set for what is due next Tuesday. SOL A2A, 2B, and 2C. It seems like a lot, but it's really just a little bit more than what you just did. I will say that these 3 sections we have not covered yet, so you may not know what to do. Try putting it into Desmos, see if you can play around with it. You can come to me, I can walk you through it. You can look at, there's a go formative, you can try doing it in there, looking it up, all of those things. So it's okay if you don't get many of those. I'm just trying to see if you can do any. Once we go through those, go through that and learn how to do it, I want you to go back to it and see if you can retry it now that you know it. But that'll be like after next unit. Okay, so 2A, 2B, and 2C are due on Tuesday. I know 2B and parts of 2C you can definitely do in deadlines. 2A, you might struggle. Alright, moving. So today we're going to talk about graphing linear inequalities. You may want to get a ruler. So, graphing linear inequalities are very similar to graphing equations, but there are some slight differences. But like regular equations, we're going to write the inequality in slope-intercept form. If it's not already. And then because it's an inequality, we have some specific rules we have to follow. We're going to use different types of lines. We're going to use a dashed line if it's less than or greater than, strictly less than or strictly greater than, and a solid line if it's less than or equal to or greater than or equal to. We'll talk about the difference between those here in a moment. And then because these graphs are going to show all the different solutions, I could put points at all of the different solutions, and it would be all of the whole numbers, but it would also be all of the decimals and fractions in between, and that would be a lot of dots to fill in. So instead of filling in all of the dots, they shade it. So to shade this, if it's less than or equal to, we shade below. And then greater than or equal to, we shade above. So then let's try number 1. So this is already in slope-intercept form, so we don't have to worry about that. Start this like normal at -5. Slope is 1/3, so up 1 to the right 3 as many times as possible. Down 1, left 3 as many times as possible. And then to look at the line, the type of line before you graph that line. Is this going to be dashed or solid? Dash. So you don't have to write the word dash, but I'm just going to for right now, if it helps you do that. So when we make a dash line, you can do it one of two ways. Just put little tick marks in between the dots and draw arrows at the end. Or you can draw the entire line and then erase parts of it. How you do that is really up to you. And then to shade it, we look at the symbol again. This is greater than, so would it be shaded above or below? Above. And to see the above, so some of these graphs are easy to see than others. Look at the y-intercept. You can draw an up and down arrow. Up is above, down is below, so if you ever get stuck, you can do that. And then you can shade every square. You can lazily shade as I'm doing. You can highlight it just somehow to show that this is the shading area. Questions on how the graphing piece works? Then we have to determine if these points are solutions. If they fall in the shaded area, they're solutions. If they don't, they're not. So 0, 0, would that be a solution? fall in the shaded area?
Yeah.
Yes. 0, -5 falls on the line. We'll come back to that one. 3, -2. Is that a solution? Yes. 5, -6. Is that one a solution?
No.
No. And -7, 3.
Yes.
Yes. So in general, if you get a point that falls on a dashed line, it's not going to be a solution. But if you want to double check, just in case you forget that rule, you could take the inequality and take this point and put that in for x and y and double check to see is it true or false. So if I were to put x and y into the inequality, we have -5 is greater than -5. Is this true? No. -5 is not greater than -5, so that would not be a solution. And you could do that with any point to make sure that you've graphed it correctly. Questions there? Okay, let's do number 2. Alright, so go ahead and graph that one like normal, starting at -1. Your slope is -2, so up to left 1 as many times as possible. Down to right 1 as many times as possible. Lesson. This would be solid or dashed. Solid. So a solid line is like a regular line. You just connect all the points and draw your arrows at the end. And then would this be shaded above or below? Below. So for this one, below, if I were to draw my arrows at the y-intercept, would be underneath or to the left. If we were to look at these points, -3, 6, would that be a solution? No. 0, 0, would that be a solution?
No.
Also no. 0, -1 falls on the line, we'll come back to that one. -4, 0. Yes. And 4, -3. So for the 0, -1, opposite of what we just did, if it falls on a solid line, it should be a solution, but you can still double check. If I take the inequality and I put that order pair in for x and y, is this a true statement?
Yeah.
Yes. It is less than or equal to, so that would be a solution. Questions on that? Go ahead to the next page. We're going to do number 3, and then any randomly see you go over the question box. So for number 3, this is not in slope-intercept form. How can I get it back into slope-intercept form? How would we rearrange this? Ariana, what did you do? subtracted 5x. And then divided everything by -2. What happens when we divide by this negative? The sign flips. So that's really important with your graphing, because if you don't flip the sign, you're going to graph it incorrectly. So this is now y is less than positive 5 over 2x minus 6. So go ahead and graph that. Would this be dashed or solid?
Dash.
And then shaded above or below? Below. So below would be to the right. Give me one order pair that would be a solution.
Or -6.
If that works. Someone else give me another point that would be a solution. Sure. Someone else give me another point that would be a solution. That works. And someone else? Or I can pick someone. 6. Let's do one more. Okay. So in general, yes, that would work. We want points that we can see on the graph, even though these graphs would keep going forever and ever, and that would work. I could say like 10, -10, and that would also work. But in general, we want points that we can see on the graph, on this graph. Okay. On this page, do we have any other questions that we want to see? Do go over, have questions on.
Number 6.
Any others? Seven. See, what were you gonna say? Alright, we'll do those 3 and then we'll move on. So 6, like number 3, we have to solve first. Get rid of 3x. You can put +0, you can leave it off, that's up to you. Divide both sides by 2. Is the sign going to change here?
No.
No. Again, you can put the +0, you can leave it off, but you are starting at 0. And going up 3 to the left 2 as many times as possible. Down 3 to the right 2 as many times as possible. Would this be dashed or solid?
Dash.
And shaded above or below? So below would be everything to the left. Give me one order pair that would be a solution.
-3. So maybe
-3 what?
0.
0. 7 and 8, we need our koi bucks. So for 7, since this is a y inequality, it's going to be a horizontal line. So on the y-axis, put a point at -4. Would this be dashed or solid? Solid. So at -4, draw a solid horizontal line. And then for your y inequalities, it's really easy to see above or below. So this should be below, which would be everything down here. And then give me an ordered pair that would be a solution. -6. So it would have to be an ordered pair of x and y, -6 what? Remember that when your line is solid, you can put points on the line too. Okay. For number 8, because this is an x inequality, it's going to be a vertical line. So on your x-axis, find 6, put a point there. Would this be dashed or solid?
Dash.
Draw a vertical dashed line. Make sure you have your arrows at the end. And then with your x is kind of like your number line, you have to think about which numbers would be greater than 6. Numbers to the right or numbers to the left. Right. So we would shade to the right. And then give me an ordered pair that would be a solution. Seven, really anything on this would be great. If we were looking for points outside of this graph, a million would be great. Because it would work. Really any y value and any x value past 7 or greater. Do we have any questions in general on how we graph linear inequalities? And we're going to get into writing, so we're going to flip the page. Okay, and writing is just the opposite of what we're just doing. We just have to remember our rules, identify the slope and y-intercept, determine the type of symbol based on the type of line and where it's shaded. Solid lines are easier to determine than dashed lines. But let's start with number 1. So we can find the y-intercept, it's at 8. To find the slope, we have to think of another ordered pair that would fall on this line if the dash lines weren't there. If it was a solid line. Where is another ordered pair on this line that it should fall? 2, 4. Okay. So then if we count the slope between those points, I'm going down 4 to the right 2, so that would be -2. If my slope is -2, I have to check that throughout the entire line. So if I go down 2 to the right 1, I should end up at another point. Keep doing that all the way across the line. If your slope is right, your points and your line will line up. If your slope is incorrect, your line and your points will go like this. They'll be off. But that was not the case here. So our slope was -2x. We know this is a dashed line, so it has to be less than or greater than. If we look at the y-intercept to see where it's shaded, is that above or below?
Upper.
above. So would that be greater than or less than? Greater than. Questions on that one before we do the next one? So for number 2, what is your y-intercept there?
4.
-4. And your slope?
1.
1. Very easy to see on this. You could plot the points to double check it, but it's not necessary for the solid lines. You can put 1x or just x. This is a solid line, so it has to be equal to. Is it shaded above or below the line? Below. So would that be less than or equal to or greater than or equal to?
Less
Less than or equal to. Have any questions on that? Go to the next one. Find any questions you want to see to go over how questions are. Do we have any questions we want to see do go over? Four. Okay. Okay. Number 4. What is the y-intercept there? 1. And look for another point that would fall on this dashed line, another ordered pair. Have to fall at the grid lines exactly, so be careful. So that looks like our slope would be 2, but let's double check it. If we go up 2 to the right one, it seems to be working so far. Down 2 to the left one. So that is our slope. If the point was off, or like it looked like it was at the grid lines, but maybe it was a little off, when you go to count your slope, you would see that it's not that. But this was that. So positive 2x. This is dashed. Would this be shaded above or below? Above. So which symbol would that be? Strictly greater than. Okay. Questions on that one? Alright, and then number 8. This is a vertical line, so we're going to be using our Hoy box again. Because it's vertical, it has to be an X inequality. It's a solid line, so less than or equal to or greater than or equal to. It's at 3. So which symbol would that be? Just strictly less than?
Less than
these numbers are less than 3, and we have a solid line. Questions on that? Okay. We're going to switch gears, and the last thing we're going to do today is systems, but if you want to take a second and stretch, get out of your seat because you've been sitting for a minute, you do that. Last thing that we need to learn for inequalities is systems of. So everything we learn with systems of graphing period, graphing linear inequalities, all of that gets combined here. On your notes, these are like highlighted over or blanked out. So if you want to write these in, you can go ahead and do that. Some of the graphs on this page are a little small, the first 3 graphs and the inequality, so we're going to do the very last one instead. You may want 2 different writing utensils or 2 different colors for this. You can use the color pencils, in the color drawer if you need to. So for this first one, we have to solve this, get it back in slope-intercept form by adding 3x to both sides. And divide everything by 5. So we can go ahead and graph that one. Would this be dashed or solid? Shaded above or below? Shade that. I'm going to draw this in lines so it's a little bit easier to see when we do both. Right, and then the other one is already graphed for you. Oh, sorry, not graphed for you, solved for you. So you just need to graph that one. Would that one be dashed or solid? Shaded above or below? Above. So that's going to be everything over here. So then you have a couple different options. You can use 2 different colors to show where they overlap. You can use maybe the same writing utensil but different line directions. You can highlight over the overlapping area. Something that shows this is the overlapping. And then for your solution points, if it falls in the overlapping shaded area, then it's a solution. If it doesn't, then it's not. So would -2, -2 be a solution? No. 1, -1. Yes. 1, 1. Yes. 2, 5. No. And 6, 0.
Yes.
Yes. Like your regular graphs, if it falls like on the edge of the overlapping, but on the dashed line, it's more than likely not going to be a solution, but you could take that point, put it in for x and y to both. If it works for both, then it is. If it doesn't work for one or both, then it's not. If it falls on the edge, but it's on the solid line, I would still double check it, because sometimes it works and sometimes it doesn't. It should work for the most part, but sometimes there's a rare case where it doesn't. Questions on that? We're going to do 2 more things with systems and then be done. Go to the next page. Number 2 did not shade well on the paper, so you should go ahead and shade that in. We're going to do number 1. We have to state the system of inequalities and state a solution. I'm going to change the color of these just so it's easier to talk about. You don't need to do this, but you can if you want. Okay, so for my now pinkish purple line, what is that line intercept? And then what is the slope of that line? One. But -1. You don't have to plot the points all the way down to see that, but you can if you want. And then as a solid line, is this shaded above or below? Below. So this would be which symbol? Strictly less than? Less than because of the solid line. Okay, for your other line, what's that line intercept? For the close. Negative. And then we're using the slope this one. So if we think the slope is 1, just double check it, because sometimes it looks like it's 1, but maybe it's something like 2/3 or 3/4, 5/6, something really close like that. So it could be off, but double check it anyway. In this case, it's not that case. Slope is 1. This is a dashed line. Is this shaded above or below? Above. So this would be which symbol? And give me 1 point that would be a solution. Say that one time. 0, 0. Sure, that would work. There are others, but that one works. Do we have questions on this one? Are there any others on this page we want to see you go over, have questions about? line here, where is that y-intercept? And then, what do you think that slope is? -2 for the slope. It looks like it's -1. And then at the y-intercept, that doesn't really help us where the shading is, but if you were to draw that same direction arrow all the way up your line, you could see that. Which symbol would that be? And then for the other one, I see the y-intercept is at +3. Right this second. What is the slope of that line? And then at the y-intercept, which symbol would that be? Is it shaded below the y-intercept?
Greater.
And someone give me 1 point that would be a solution. -2, so right here. 2, +2. That would work. -2, +2. Okay. I did not say this before we started graphing, but the graphing and systems of will be no calculator on the quiz on all the tests. But while you're practicing, I'm going to show you how you could check yourself in Desmos in the calculator. All the steps in the calculator are on the next page. But in your calculator, go ahead and reset it, 2nd plus 712. And then go into the apps button, the button right next to math. And you're going to find something that says inequals. There are more apps in my calculator than in yours. You should really only have 4. If you don't have inequals, raise your hand. I fixed a lot of them earlier. Do you not have one? Did you go into apps? And then once you go into inequals, hit enter. Or once you're on inequals, hit enter. You should see a screen that looks like this. And then go into your y equals. And if you're not hovering over the equals, it looks like normal. But if you are hovering over the equals, you can see these symbols at the bottom. And we're just going to do the 2 examples that are in the notes. Y is less than 3x plus 2. So to change the symbol, you're going to use alpha, then whichever button. So for less than alpha window. And you should be able to see that the thing off to the side will change to a dotted or dashed line where it's shaded below. And then if you move away from that, you can put in the rest of the inequality, 3x plus 2. The issue with this app is you can't use your alpha y equals to use your fraction bar, so you have to put fractions in parentheses. So if we change this to a greater than or equal to, that would be alpha graph. And you'll see that it's now a solid line shaded above. Then you can use parentheses, -1 divided by 2, and then outside of the parentheses, x minus 4. Once you have both of those, go ahead and hit graph. Your lines will be in black and white, but mine you can see in color, and it should show you the overlapping region. In this button shades, if you hit alpha y equals, you'll see this menu pop up. So the original shade, that's what you just saw, the graph on top of the other graph and the overlapping. If you go into the number 1, you're able to see just the overlapping. So did I do this right? Did I graph this right? You can double check that. But if you go back into alpha y equals and go into number 2, that doesn't really help. It just shows you everything, the overlapping and the originals, and you don't really need that. So 1 or 3 is great. 2, not so much. Questions on how to check yourself in the calculator? Desmos is easy. You just type in the inequalities. I'm just going to make up 2 random ones really quickly. So you can see the 2 graphs overlapping. You can see the type of lines. You can put in ordered pairs to see if it would fall in the overlapping shaded area or not. That one is a solution. So you can use that. Questions on how to check yourself in Desmos or the calculator? You guys have a bunch of different things you can be working on. You can keep practicing in either of the notes, graphic or systems. You can work on the SOL practice that's due next Tuesday. Work on any of the 3 Delta Maths that are due Friday, compound and absolute values, graphing, or systems. Or if you didn't finish the Delta Maths from last week, you can be working on that. So use this time wisely, ask questions if you have them, work together.